Okay, we are looking at the sampling distribution of the difference in two sample proportions now. So we have two independent samples. You guys understand the difference now, of sizes N1 and N2. We have two different populations. Now we know that each one of these will have a P1 hat and a P2 hat. P1 hat is made up of the number of successes in population 1 out of N1, and P2 hat is the number of successes in population 2 over N2. And so if we take the subtraction P1 hat minus P2 hat, of course, this is going to have its own distribution. And the mean of that distribution, we know, is P1 minus P2. And the standard deviation of this looks like this. I know it's a mess, isn't it? Okay. So we're going to use that on the next couple of slides to see what we need to do for our both our confidence interval and our hypothesis test. So, of course, again, the central limit theorem states that the P1 hat minus P2 hat will be approximately normal as long as N1 and N2 are large enough. So let's move on. Again, what is large enough N? All right, in this case, the first thing we need to do is find our P pooled, okay? So we need to find our P pooled hat. And that is, we treat the two populations as if they were one. And we have all the yeses out of all of the N1 and N2, both population sample sizes added together. And this is how we figure out, we just treat it as if it were one population, the yeses out of the total, right? Then we figure out all of these things. Well, we don't really have to figure out all of these things. We really only need one of these. We need to figure out which one is the smallest one. So N1 times PP hat. I forgot my hats on all these. And actually, I'm not going to use hats because it should be my P. If these are equal, then this is the same anyway. But this is how we actually figure it out. It actually is hat. So N1, because if the two populations are exactly the same under the null hypothesis, because that's what we're going to be doing, P1 is going to be equal to P2. And if that's true, then it is just one population, and the P hat is a estimate of that population, the best we have right now. So N1 times PP hat is greater than or equal to 5. N1 times 1 minus is greater than or equal to 5. N2 and N2. So we only really need the smallest one. So what we do is we figure out which one of these has the smallest sample size. So we have N1, N2, and here PP and 1 minus PP. Now I want you to think about it. These are all four things that we need, right? N1 PP, N2, I should give these hats, I keep forgetting, and N1, 1 minus PP, and N2, 1 minus P. Okay, now one of these two is going to be smaller, right? So we take the smaller of these two and the smaller of these two. So if this is less than 0.5, P hat is less than 0.5, we're going to use one that's in this row. This is if PP hat is greater than 0.5. We use one in this row. And here, N1 is smaller, N2 is smaller. We use them in this column. So if N1 is the smallest and my PP is less than, not 5, 0.5, that's what I meant to say, is less than 0.5, I'm going to test N1 P hat. If n2 is smaller, I'm going to test n2 p hat. If n1 is smaller, yet my original pp was larger than 0.5, which means 1 minus the p hat is less than 0.5, then I'm going to use this one. And finally, if n2 is smaller and my original p pooled is more than 0.5, I'm going to use this one. So really, I only have to test one thing, whichever one of these four things is the smallest. Because if the smallest is less than 0.5 or is less than 5, I can't do it. Doesn't matter. But if the smallest is greater than 5, then the rest of them will also be greater than 5, right? If the smallest thing's more than 5, everything else is going to be more than 5. All right. So let's take a look at this. Our null hypothesis for this test is as follows. Again, we're just going to say P1 is equal to P2, and then it's either less than, greater than, or not equal to. So, and our test statistic is a standardized form of our P hat minus P2 under the null. And under the null, P1 equals P2, so P1 minus P2 is 0. So, if you look at this, we have P1 hat minus P2 hat and divided by, now notice what I've done here. I've actually taken the PP hat and the 1 minus PP hat and put it separate of 1 minus N1 plus 1, or 1 over N1 plus 1 over N2. That is because, remember, I'm assuming that the null is true and the P1 equals P2, which would mean that my PP hat is an estimate for the overall proportion if these two are the same population. So, again, we would use this Z, use normal CDF, calculate our p-value. However, most of this we're going to be doing on the calculator. So, we make our assumptions. Again, SRS, and we have a large enough N, according to the rules on that page. And again, always write down your null and alternative first. And darn, I have a typo in here. That should be 6. 2 prop Z test. Sorry, fix that if you've printed out these. And X1 is the number of successes in sample 1. N1 is sample size 1. X2, obviously, you guys get the idea. And then your P1, you're going to highlight either not equal to, less than, or greater than. And then here's our output. I'll talk about that when I get it. And so let's take a look. We want to compare the Alaska Native students at UAA and UAF to see if they're the same percentage. A sample of 245 UAA students found that 31 of them were identified as Alaska Native. Oh, I'm getting deja vu. A sample of 205 UAF students found that 40 students were Alaska Native. The data indicate a difference in the proportion of UAA and UAF students who are Native Alaskan. So, first of all, we want to make sure that what we're doing is not against any of our assumptions. So I'm going to figure out what PP hat is. That's 31 plus 40 over 245 plus 205. That's 71 over 450, I believe. Okay. Shh. Sorry, I have a cat. And usually this is quieter to do at home than in my office, because usually there's lots of things in my office. But however, right now, my cat's decided I'm talking to him, apparently. Okay. So 71 divided by 450 is 0.158. So now, that's less than 0.5. So now we need to multiply that by the smaller of our n. So 0.158 times 205 is, so 0.158 is our p hat times n2 205 is 32, which is greater than 5. We're okay. Our assumptions are met because the smallest of the all four having to be greater than 5 is more than 5. So all of the rest of them will be. So now that we have that, now we can write down our null and alternative hypothesis. Now I don't have to say 1 and 2. I can actually say P of A is equal to P at Fairbanks, or does it indicate a difference? P of A is not equal to P of F. I can write it like that. I can write it 1 and 2 as long as I keep track what I'm going to call UAA population 1, UAA population 2. Okay, so far so good, right? We've written down our null and alternative hypotheses. Now we know that x1 is 31, n1 is 245, x2 is 40, and 2 is 205. So let's go to our calculator. So we go stat, tests. We're going to go to a 2-prop z-test, which is number 6. That's why I changed it on the other page. So we go 2-prop z-test. And we're going to fill everything in here. 31, 245, 40, 2, whoops, not 2.5, 2, they won't let me do, 205, not equal to, calculate. So it looks like my test statistic Z is nearly 2, 1.99, and p-value, notice I always write PV because I don't want to get that confused because I never want to compare that, is 0.047. Ooh, close. And this also gave me P1 hat. I'm going to go ahead and write that down. So P1 hat is 0.126, or 127. We already did that before. P2 hat is 0.195. And notice it gave me P hat also, 0.158. So that's my PP hat. So it actually gives me a lot of things. If I scroll down here, it'll give me more. Gives me my N1 and N2 again. Gives me lots of good information. Okay, so here's our P value. So based on our P value, what would you do with this? At the 5% significance level, I didn't say. So if it doesn't say, we're going to use 5% significance level. So we're going to reject the null. At the 5% significance level, we have enough evidence to conclude the proportion of students who are Native Alaskan at UAA and UAF are different. So we have enough evidence to say that we're different in that case. Good. That's good to know. Oops, I don't need that camera on. Okay. Oh, it was the ceiling. Okay, so let's talk about a confidence interval, and I'll just stay here for just a second, or you can pause it. Ready? Go. Okay. So our 2-proportion confidence interval. Now, this is what it looks like if we do it by hand. So we just take our P1 hat minus our P2 hat because it's a confidence interval for the, that's what I get for copy and pasting things from before, the difference in true proportion. So the formula looks like this. We use the Z, and we do have to separate each one of these out because in this case now, we're not assuming anything. Not assuming anything when we make a confidence interval. So And that's why it's a little bit different. So when we do the confidence interval, we're doing 2 prop z int. And here's all our inputs, about the same as we did before, except for, of course, we put a C level here. So let's do a 95% confidence interval for the difference in proportion of students at UAA and UAF. And we're going to see if this interval includes 0. So we're going to go stat, tests, and down to, come on, go. 2 prop z int, it's B. So 31, 245, 40, 205, C level is 95%. Everything's already in there. Boom. So looks like one of these is in scientific notation. It says, and -2e -4. And again, it gives me my P1 hat and my P2 hat. It doesn't need a P pooled hat because we're not making that assumption. Oops, that's 7. 195. Okay, so looks like we have -0.137. This is our difference in proportion. And this is -0.0002. So we are 95% confident that the true difference in proportion of Alaska Native students at UAA and UAF is between -13.7%. I don't like that. Percentage points, if you want to say it that way. And -0.02% points. So there may be just a little tiny bit difference. So the difference may be as small as this, but does this interval include 0? Since the interval does not include 0, then we can be confident that there is a difference in percentages. So our interval doesn't have 0, it's negative, it's all on one side. So it looks to me like, if I were interpreting this, I would say that the percentage of students at UAF, or UAF has a higher percentage of Alaska Native students than does UAA, which I think makes sense, actually. So there you go. And so that's all for this one. This one's only 20 minutes, so enjoy it. We'll have some fun in class for this one. We're going to have M&Ms, so it'll be kind of cool. So I will see you guys in class.